We navigate the world assuming space is a passive, perfectly flat stage. We rely on the comfort of classical order, trusting that Euclidean geometry, like the Pythagorean theorem, will always hold true, no matter where we draw our lines. But step outside that flat mathematical plane, and those rules break down. In curved space, calculating the distance between 2 points reveals a physical quirk known as the collapse of the hypotenuse. Look at this 3D globe. If you start at the equator, walk 180 degrees east, turn 90 degrees north, and walk another 180 degrees, you end up at the exact same point on the opposite side of the planet. There is no diagonal line connecting your start and end points. The paths simply collapse into a single meeting point. What feels like a rigid, predictable grid in our daily lives is a local illusion. We are living inside a deeply curved, dynamic geometry that remains entirely hidden from our macroscopic view. This illusion of a passive stage is so convincing that it is baked into classical physics. Take Einstein's equivalence principle. This is the foundational idea that resting in a uniform gravitational field is locally indistinguishable from being inside an accelerating reference frame. There is a catch to that rule. The equivalence principle only holds up if you are looking at an infinitesimally small point in space. The moment you apply it to a physical, extended object, something with an actual top and bottom, the math tells a different story. This diagram shows a suspended ball in 2 scenarios. On the left, in Earth's gravity, time actually runs faster at the top of the ball because it sits at a higher gravitational potential. But on the right, inside an accelerating rocket, the floor pushes up on the string, dragging the ball along from below. Here, the bottom of the ball experiences more proper acceleration, meaning time runs faster at the bottom. This reversal identifies space as a reactive medium, a physical participant that shapes how matter experiences the passage of time. If space is a reactive medium rather than an empty room, we have to rethink how we move through it, especially if a human or a large object wanted to cross it instantly. Standard quantum teleportation has a strict limit. To teleport anything, you need an independent, entangled pair of particles for every single degree of freedom you want to move. Here, we see the scale of that problem. A human body contains roughly 10 to the 23rd power particles. Tracking, isolating, and entangling that many individual particles creates a computational wall that is physically impossible to climb. We cannot cross this barrier by moving the particles themselves. Instead, we have to look at the space between them. This brings us to a concept called quantum entangled localizations, or QEL. QEL proposes that space-time itself is a quantum framework, and its geometric structure can actually be entangled. Think of space-time as a vast, continuous net. The physical matter inside it, stars, planets, you and me, are just the fish caught in that net. Matter interacts continuously with geometric fluctuations through the stress-energy tensor, the mathematical description of how mass and energy exert pressure on surrounding geometry. This coupling means an object's location is effectively a state of the geometry it is currently bonded to. By entangling geometric degrees of freedom in 2 regions, we entangle the matter's anchor points, creating a bridge between the substrate of region A and region B. When these correlations shift, the object relocates instantly without traversing the space. The attached net is rewired. Location is not an absolute coordinate. It is a quantum relationship between matter and its geometric anchor. If the fabric of space is this dynamic and relational, we have to ask what that means for the ultimate canvas we exist on, time. The traditional view in physics is the block universe. In this model, every event in the past, present, and future coexists equally within a static 4-dimensional block of reality. Everything is pre-written. But the block universe struggles to explain why time seems to march strictly forward. It relies on the past hypothesis, an assumption that the universe started in a highly improbable state of low entropy, meaning extreme order, to explain why things decay and time flows in one direction. A newer alternative is the evolving block universe. In this framework, the block of reality isn't static. It actually grows, generating new space-time as the present advances forward. As we see in this model, the evolving block universe physically grounds the irreversible arrow of time. The natural increase of entropy, the universe's transition from order to disorder, actually drives the active growth of reality itself. We spend our lives trying to measure and clock this unfolding reality. We build increasingly precise instruments to capture the exact moment the present edge pushes into the future. The matter composing our bodies remains intimately coupled to this growing, entangled substrate, an architecture that actively constructs itself one moment at a time.